Hey, Algebra 2 kids, today we are reviewing how to simplify exponents. And so I gave you a homework sheet that has problems on it for exponents, and then you should also have a sheet that looks like this that gives you all the properties of each. So I'm going to go through each one of these properties. This should be review, um, but I'll give you some examples that go along with the properties, as well as like some harder examples to show you what happens when things get a little bit when the equations get a little bit longer. So um, the product of powers property is when you're multiplying two things that have the same base, you're adding the exponents. So that is, like, I use this example all the time: x squared times x to the third power. You're adding those exponents. That's x to the fifth power. Okay, people get that confused a lot with the power of a power property, where you have x squared to the third power. They look at this one, and then they look at this one, and they say, well, which one do we add and which one do we multiply? On this one, you multiply. When they're stair-stepped like that, you multiply them together, and that becomes x to the sixth power. So I'm going to go down here, and I'm going to show you a little bit longer of an example. So let's say we have like 2x to the third y squared z, 2, and negative 3xyz to the third power. Let's do that one. Okay. If at any point in time you need to pause, feel free to do so. We're going to multiply all these together. So we start with just the numbers. 2 and negative 3 will just give me negative 6. Okay, and then x's, I have 3 x's here and 1 x here. If there's no exponent, you pretend that there's a 1 there. So 3 over here and 1 over there makes 4. So x to the fourth power, and then y squared times y will give me y to the third, because there's 1 y here. These z's, this is 1 here and 3 there. So again, I'm still just adding, and it's z to the fourth, and this is what I get as my final answer. So when there's a bunch of different ones, you just do the same thing. You're just adding those exponents. Okay. Now, this third one, the power of a product property, is when you have multiple things inside of a parenthesis and you're taking that to some power. That power is kind of distributed for both of those pieces. So a to the m power, b to the m power. Okay, an example of that would be like if I had x squared y to the third power and I was taking that to the fourth power. Okay, I would distribute that 4 through, so that would become x to the eighth and y to the 12th. Okay, a little bit trickier of an example. If you want to write this one down, let's say I have 4x y to the fourth z to the fifth. So just a little bit harder. And we want to square that. Okay, so again, that z is going to be, or that 2 is going to be distributed for all of those pieces. But the thing that people forget the most is that this 4 also needs to be squared. Okay, and you're not taking 4 times 2, you're squaring the 4. So 4 squared becomes 16. Okay, you're not multiplying by 2, it doesn't become 8. And then if I take and square the x, this is x to the first power. Here I'm multiplying the exponents. So that becomes x squared. Ooh, I'm really fuzzy right now. There we go. X squared, y to the 8th power, and z to the 10th power. You're just multiplying those exponents, but make sure that if you have a number out in front, you square him also. You're not multiplying by 2, you're squaring him. Okay? The negative exponent is the fourth one down. And that is if you ever have a negative exponent, you can move him to the denominator, but also if you have a negative exponent in the denominator, you can move him back up to the top. So an example of this would be like if I have 4 to the negative second power. Okay, that's the same thing as writing 1 over 4 squared, which is actually 1 over 16 if you square the 4. But in addition to that, if I have 1 over 2 to the negative third power, where the negative is in the bottom, I can move him back up to the top. So that will become 2 to the positive third power, or 8. 2 to the third power becomes 8. So I can move those either to the denominator or back to the numerator, depending on whether they have a negative or positive exponent. So a harder example that goes with that would be something that looks like let's say I have 2x to the negative fourth power over y to the negative sixth power. Okay. Now the thing that people screw up on this one is that the negative fourth power is only going to the x. The 2 is going to stay in the same spot. So the 2 is going to stay up here in the top. The only thing that I need to move is the x, and then I need to also move the y. All right. So the x, if he comes down to the bottom, will change that to a positive fourth power. If I move the y to the top, it would become y to the positive sixth power. And that's all I have to do. The 2 is going to stay in the same spot. The other two ones are going to switch because those are the ones that have a negative exponent. A lot of people think that the 2 and the x go together and the 2 should come down below also. That is not the case. Only if 2 had a negative exponent here, I'm fuzzy again. Only if 2 had a negative exponent here, like in this example, would you move him. Okay, but he doesn't have an exponent of negative 4, so you do not move that 2. Okay. Almost done here. The zero exponent property is the third from the bottom. That just means anything to the 0 power is 1. So 4 to the 0 power is 1. 2 to the 0 power is 1. X to the 0 power is 1. Anything to the 0 power is 1. Now, there's an exception to that, and that is negative numbers. So, example 4. Let's do this. I just said that 2 to the 0 power was 1, okay? If I had negative 2 to the 0 power, that instead would be negative 1, okay? But to get a little bit more confusing, if I had negative 2 to the 0 power like this, that would be positive 1, okay? And that's kind of similar to when you have like negative 2 squared and negative 2 squared like this. This one is only squaring the 2 and then applying the negative, so that would be negative 4. This one is squaring the negative and the 2, so that would be positive 4. So kind of in that similar way, if it's in parentheses and it's to the 0 power, it stays as a positive. In parentheses to the second power, it stays positive. But if it's not in parentheses, the only thing you're taking to the 0 power is the 2, and then you're applying the negative. The thing that you're taking to the second power is 2, and then you're applying the negative. So that's kind of how that works out. If you have a negative there, that zero exponent property kind of stays negative. So that's the only exception to that. The quotient property, if I have two things that I can put together, like let's say x to the third power over x, there's 3 of them on top here, and there's 1 of them on the bottom here. So this x that's on the bottom can cancel with 1 of them up on top here, and that would just leave me x squared on top and none left on the bottom. So this 3 becomes a 2 because I've taken 1 of them away from the bottom. And really, if you have a 1 on the bottom, you really don't need it. You can just leave that as x squared. Okay, so that's kind of what a quotient looks like. Let me go ahead and give you, actually, let's go over this next property, and then I'll give you a harder example. So this one here says it's kind of similar to the power of a product property where you distribute that exponent. This one you're distributing the exponent also. So even though you have a numerator and a denominator, that power of m, whatever m might be, is going to go for both the top and the bottom. So an example of that would be like 2 x squared over y to the third power, and let's say I'm squaring that. Okay, so again, we have that number there. You're still going to square the number. So that will become 2 squared, which is 4. The x will become to the fourth power, and the y will be to the sixth power. You're multiplying those. So that's a little easier of an example. I'm going to do another example down here. Okay, example 5. I'm writing down a lot of examples, so if you need to pause, make sure you go ahead and do that. So this one, I've got 3, let's say 3x z to the third. It's fuzzy again, sorry. 3xz to the third over 6z squared x to the fourth power squared. Okay. Now, there's z's and x's and numbers all inside of here. So there's 2 different options that you could do. You could go ahead and simplify what's inside of here before you square it, or you can square everything to start with and then simplify. I think that's what I'm going to do. I'm going to square everything to start with, and then I'm going to simplify. So 3 squared becomes 9. X squared, this is like x to the first power, that will just become x squared because you're multiplying the 1 times the 2. And that will be z to the 6th power. 3 times 2 makes 6. So that's what I will have in the top. And in the bottom, 6 squared will be 36. Z squared and then squared again will become z to the 4th power. And x to the 4th squared will become x to the 8th power. Okay? Now I'm going to go ahead and reduce things. So I start with the numbers. 9 and 36 will become 1 and 4. 9 goes into 36 4 times. So 1 and 4. Okay? And then the x's and z's. The x's, I have 2 x's up here and 8 of them down below. So when I subtract those, I get 6 of them. But since the larger one was in the bottom, I'm going to have the 6 x's go down in the bottom. Okay? Imagine that I have like 2 x's up here and I have 8 of them down here. 2 of those are going to cross out with 2 of them down here, so I'll still have 6 left in the bottom. And then I have z to the 6th on the top and z to the 4th on the bottom. So I will just have 2 z's on top. All 4 of these will cancel with 4 of them up there, so I'll have 2 of them on top yet. And that's my final answer. There's nothing more that I can do to simplify. Okay. The only other thing that I'm going to tell you with these properties is they're going to start to combine some things. So let's say that I have 2x y to the 2nd z to the 4th, and I have that squared, and then I'm multiplying by negative 4x z to the 3rd power. Let's say I'm doing that. Okay. So it's like, what part do I do first? You're going to always do the parentheses and exponents first. So that's the part of the PEMDAS. All right, this is example 6. So exponents, you're going to do the exponents first. Since this 2 is here, I'm going to distribute that 2. I really have 4 pieces inside of here. The 2, the x, the y, and the z. So if I take 2 and I square that, that will become 4. The x, if I square that, that will become x squared. The y, if I square that, that will become y to the 4th power, and z will now be to the 8th power. So I've done that square for everything, and then I've got this negative 4xz to the 3rd power behind it. Okay, it doesn't have an exponent that it needs distributed, so I'm just going to leave him the way he is now. Okay, and now these 2 pieces, since they're both in parentheses, there's no operation in between here, so you kind of just assume that you multiply. So I'm going to look at the numbers first. 4 and negative 4 becomes negative 16. X squared and x, this is again x to the 1st power. And you're not multiplying those exponents. Since they're side by side, you're going to add them. So I'll have 3 x's. There's a y here, but there's no y over there. So he'll just stay as y to the 4th power. And there's 8 z's here and 3 z's there, so that will be z to the 11th power. So that's simplifying. So there was just kind of 2 different operations that you were doing there, one with a power, and then you're going to multiply them both together. So you might end up having combinations of things. Just take everything step by step, write out all your work, and it will be okay. All right?